I was like, oh, mind blown. I was like, so you're telling me.
What is going on? Come on.
I was actually really intrigued by your like information on Thingiverse. I was like, where did you learn?
You made up all of that. You made up some documentary, and
All right.
No.
Thank you, everyone, for presenting your sketch models. I think for the most part, you guys hit the assignment on the head. These were not supposed to be beautiful, like perfectly constructed things, just something to get your head back into the 3D space, thinking about real volumes in a way that's different than drawing on 2D page. So nice job. Hopefully you guys didn't have to spend more than half an hour or so on each of them. Unless you were really into details and stuff, that's fine. So, like I said, when we were talking individually, I'd encourage you to pick one of those ideas and take it the next step. So we're going to be, in the next like 45 minutes or less, hopefully, talking about some of the considerations you need to be aware of when you're refining your design in 3D for 3D printing. So I'd like to kind of start off, I'm sure probably most of you have already seen a 3D printer work. There are lots of different types of 3D printers. The most common of them is a FDM printer, fused deposition modeling, or making. Basically, the way these work is it'll take a spool of plastic material. A lot of times it's something like a cornstarch-based plastic, like a PLA, if you hear that term. It's very inexpensive, not super awful for the environment. The print head will heat it up into a goop, kind of like hot glue, and it'll print layer by layer whatever 3D geometry you send to it. So, I mean, this is just one very sped-up example of a MakerBot, which is one of the printers I guess you guys have upstairs, printing something. Kind of a cool process. So one thing you can kind of notice is it prints from the bottom up, and orientation is going to matter. I don't know what that is. We don't need it. And the other thing I mentioned to you was one way that you can get a preview of how an object, a 3D object that you create in Solidworks and export as an STL file will look when it's 3D printed is by using a slicer. So I posted on Carmen a link to download Cura, which is a 3D slicer piece of software. It will basically slice a 3D model into the pieces and code that a 3D printer needs to actually print that model. There's a link to download it. This is the page that it brings you to. Cura is an open piece of software. It's free. It works with a lot of different common 3D printers made by Lulzbot, Ultimaker, several other ones. This version of Cura I'm recommending you guys get comes off of the Lulzbot site. It's a specific build of Cura for Lulzbot printers, since it sounds like you also have a Lulzbot printer. That's the printer I have, or Local Tech Heroes has. And the one that you're going to want to download is for Windows, probably, unless any of you guys are running Ubuntu or something else. And then you got to hit this button too. There will be some options. Just go through the options, download the Cura. It might ask you if you want to associate a bunch of different files with Cura. As long as you have the STL box checked, none of the other boxes need to be checked. Yeah, Mitch? Yeah. It's not going to screw anything up, but I'm not going to be able to like troubleshoot the process with you. It'll probably be pretty darn similar, and we're not actually going to be using our Cura to 3D print anything unless it's to the printer that I have. It sounds like Department of Design has its own process. Probably the only thing you'll need to provide to whoever runs the printer here is an STL file. But having access to a slicer, and I'll show you here in a second, will let you guys have a much better idea of how your design is going to print and whether or not you need to change something. It'll also give you some cool readouts on, like I mentioned before, how long your print might take, how much material it might require, and those are things that might let you calculate the cost Depends on how the Department of Design charges you. Usually it's like by weight of material and probably also time, but we'll see. So you guys don't have to download that right now, but I would definitely get it for over the weekend. The other site that we're going to be talking about a little bit is Thingiverse. Thingiverse is a really cool site. So this is a good example of like the democratization of design. And what I mean by that is Thingiverse is an open platform for anyone, not just industrial design students or design professionals or engineers, but anyone who has access to any sort of 3D modeling program can upload a design. And then anyone who has access to 3D software or 3D printer can download those designs and create stuff themselves. You can also remix or edit files. If you find something on Thingiverse that you like, but you want to tweak so it fits your situation or someone else's situation, you can download their file and edit it. It's a really cool platform. Mess around with this, like explore, see what kind of stuff is on here. For the most part, the objects that get featured are really cool. Like articulating lamp. I mean, you could 3D print that stuff right now. That's really neat. The other great thing about Thingiverse for you guys is it gives you a way to, when you design something that is 3D printable, and you put it in your portfolio, now you have a place for it to live in the real world. You can link people that visit your portfolio to Thingiverse so they can 3D print their own copy of your object. So as a design student, you can have real versions of your designs out there, and I'll show you kind of what the back end of it looks like. So I have just a couple things up here. One of those things is this S3 Ninja Star. So this is sort of a side project for me. I teach drone building and racing classes at Idea Foundry, and the quadcopters that we build are based on a 3D printed frame. It's something that I designed in Solidworks, analyzed in Cura, and 3D print. It's a very basic part, but Thingiverse lets me put not only just like pictures of my builds, you can do like, you can upload anything you want. If you want to do like beautiful Keyshot renderings and stuff and put it on here, that's fine. That's the 3D printed part and a couple variations. Components that work with the 3D printed part. A lot of you guys had mentioned how the 3D printed part you're designing, and I've even made a requirement, it has to interface with at least your phone and one other object. This is a good place to showcase that kind of stuff, right? It also lets other people who have made your thing, see down here, so like 178 people have downloaded this thing, and some of them have posted photos of Chris 4000 made one of these things, and he put a photo up here of his version of the object I designed, which is kind of cool. You guys have access to that stuff, so this is a really neat tool. Thingiverse also generates a preview of the 3D model of the file that you upload here. So that's another, just sort of like another cool feature on this platform. Yeah, Mitch. The question was, what would be the price tag of the kit put together here? I mean, the 3D printed component is like a 20-minute build. That's like 50 cents, maybe. All the components, the other components that work with this, you can buy online if you're just paying retail prices. And it works with VR goggles and stuff too for like $150 or so. Yeah. Give or take, somewhere between 150 and 200 bucks, depending on like what goggles and things that you get. So anyway, that's something I wanted to show you because we're going to walk through kind of how this part looks in SolidWorks, and we're going to take it into Cura, see how it looks in Cura, see some of the design considerations, and I'll just talk through some of that stuff. All right, so first I got to find the part. Let's see. Third nano frame. Cool. Wait. Yeah. Oh yeah, there are a couple versions of this thing. Oh, okay, so I built this with SolidWorks 2017, and I'm using the student version that you guys have right here. That is fun. That's too bad. I actually think I might have a thing file on here. Are these all STLs? They probably are. Let's try something else then. Okay. Well, I was going to open that part in SolidWorks. It looks a lot like it's going to look in Cura, so I'm just going to open it in Cura. So let me open up Cura. This is what it looks like, the Lulzbot edition. And it gives you a similar like 3D space. Of course, it has entirely different like zoom, pan, and rotate controls in SolidWorks. They're also entirely different than Keyshot. Get used to that. I don't know why they can't settle on like a uniform set of things here. You can basically do a few different things here. Off to the side, these are all settings that have to do with the 3D printer and how it prints. You guys don't have to mess with any of that for what we're using this tool for right now. The big thing you want to do is load a model. So once, and I'll show you guys how to export as an STL, but once you've exported an STL version of your file, whatever it is, you can find it and open it. So I'm going to open up the, I guess this guy right here. And it'll import the geometry to exactly the scale that it's supposed to be. So I've designed this object, I added a bunch of dimensions so that it's this size. The build size of this like checkered floor matches the size of the Lulzbot Mini, which I believe is about 8 inches by 8 inches. There are ways to change the machine that you're previewing on. Again, don't worry about that for now. Just know that it's something that you can see when you're in a slicer software. What I'm interested in is different ways to look at this model. So there are a couple different view modes off to the right side. One of them is layers. And if I click layers, it'll actually give me a preview of every single layer. And I think I can, like, let's see, zoom in a little bit closer. Every single layer that the printer is going to have to make when it prints this part, which is kind of cool. And there are a couple different things that you're seeing. So down at the bottom, and I can also like drag, let me get out of, zoom out a little bit here. I can like drag my layer progress down and see each layer by layer by layer by layer. So the first layer, it's going to print, first few layers, it's going to print a lot of this blue stuff. And by the time it gets to the top, it's not really printing blue stuff anymore. That blue stuff, these blue layers, is support material. It's the same material that it's using to make everything else in this geometry, but it's not actually a part of that model, right? When I brought this in, there wasn't this like crazy amount of material underneath here. It needs that in order to have a place to start printing the rest of this geometry on my quadcopter frame when the printer makes it up to that layer. In general, you guys are going to want to minimize the amount of support material that is required to print your models because it sticks to your model and you have to like scrape it off. It's just hard to clean up, and it adds extra time and material to your build. Yeah. It probably does need it in the middle, and that's the other kind of crazy thing here that I think. Let's see if we show overhang. Okay, so there's another view mode here called overhang, and you can kind of see by this icon. And man, I hate zooming and stuff in here. Let's see if I can. All right. Okay, basically any area that is like facing down, that's kind of an area that might need support material. And as Liam just pointed out, when we looked at the layers, it added support material for the bottom of my frame here, but not for this part. It would definitely need it there. And there's a good chance that if I went to print it in this direction, it would just fail. You'd get like a big nest of gross 3D printed material. Yeah. It can. I wanted to show you this way because one of the things that you can think about when you're designing your object, and especially when you bring it into Cura, is you can change the orientation of your object to make sure that it prints the way you want it to. So yeah, awesome. To change the orientation of your model, you'll go back to just a normal view, and you can click your model. You can drag it around, move it to a different spot on your build plate, and I'm gonna like rotate this back around. You can scale it, so if for some reason you didn't care about the dimensions of your object, like let's say it was a vase or a cup or something, you just wanted to print it as big or as small as you could, you can actually change the size of this model, drag to any size. Because these have very specific dimensions, I don't really want to do that. You can rotate your model. So this button lets you rotate, and if you click on one of these different axes, it will let you rotate along those axes. It does tend to snap. You see that like 45, 60, 75, 90. It'll kind of snap to regular angles. So if I wanted to rotate this 90 degrees so it sits flat, there we go. Now if I check my layers mode, it processes it again, and I don't see any of that blue material underneath. There is a blue outline around the edge of the model. That's just something that this version of Cura for Lulzbot kind of does by default to show you the proximity of the build before it prints. But this is kind of what I want you guys to look for. Find an orientation to print your object that really minimizes the amount of support material you need, or you might have to redesign something, or even slice your model in half and print it in 2 sections to get it to print properly. You'll also see, so there's red areas in Cura. That's like edge material. It's all printed solid. If you looked at it, it would look like a relatively solid part. And then there are these like green and yellow areas. The inside of a solid part, when you 3D print it, usually isn't solid. The 3D printer is smart and will fill it with kind of like a honeycomb pattern. So like, let's say I printed a solid shape that looks like my water bottle. It would print the outside completely solid, and then it would fill the inside with like honeycomb structure, so it's not wasting material. You know, it's not going to print 3 pounds of material for just this shape, if that makes sense. All of those things, all of those settings, like how thick the edge material is, how thick each layer is, that's all stuff that you can tweak, but that's stuff for maybe another class. If you want to get into 3D printing, there's a lot of really cool settings that you can change. I want you guys to import your models into Cura and just take a look at how they might actually print. In order to get your model into Cura, you need to export it as an STL. So I'm going to go through that process once really quick. Let me just open a file that I already have, like I don't even know what that is. Oh, my sketch model. Okay, cool. So, once I have my model of my phone accessory done, and it's, or halfway done, and I just want to see what it looks like in Cura, it's important that I export only the solid body that I want to 3D print. You can export multiple bodies, but like I don't want to see the phone in Cura. So the first thing I'm going to do is find any of those bodies that I don't want, like, oops, I didn't mean to hide that, like all of these phone parts, and I'm actually going to delete those bodies. I thought that was an option here. Yeah, delete bodies. Say, okay. You can undo that later, but just for the STL export, get rid of anything that you don't want to be 3D printed. Okay, so this is the part I want to see 3D printed. I'm going to go up to File, and I wonder if we could just do it as a Save As. Yeah, so File, Save As, and STL is one of your options. Really simple. It's just another way to save an object. There are options, STL options. You don't need to mess with these, but to put it on your radar, if you're 3D printing something that's really, really small, an STL is kind of like a raster version of a 3D file. What do I mean by that? If you guys are familiar with like how Adobe Illustrator treats graphics, they're vector, they're like math-based. You can scale them, zoom in. They're not pixelated. Photoshop treats image files as a bunch of little pixels. Same thing happens in the 3D world. A SolidWorks file or an OBJ or some other math-based file, it keeps all of your build history. It keeps all of the math and like the curves and real geometry so that you can work with it. STL is something called a mesh file. So there are ways to adjust the resolution of the mesh file. Again, not super important right now, but it does exist. So cool, I'm okay with those. Yes, I'm going to save it as an STL. I'm just going to say save. You'll get a little preview of all of these little triangles, these polygons that it turns your file into. And that's fine. Save it? Yeah. Okay, cool. So let's see what that looks like in Cura. I'm going to click my layers view, go back to a normal view here, and if I don't want this part anymore, I can right-click and delete the object, or I think I can just click it and hit delete. Either way works. All right, let's load another model. I'm going to go back to OSU stuff, and there is my demo file. Wow, and it's huge. Awesome. So the Lulzbot Mini, again, it's only like 8x8, and I must have built this thing pretty big. Probably a good example of when I might want to scale this down, and I can, let's go to like half scale. Okay, that's better. Okay, now I'm just... No, it wouldn't fit the phone. We would just have to find a bigger printer, or like cut that model in half. And actually, maybe I'll show you guys what I mean, like cut the model in half. Some of the stuff that you guys print, depending on how big the printers are, we might actually have to do in different parts. You know what? We'll save that for next week. Focus on just designing something. Yeah, exactly. Yeah, print two halves, glue them together. We could even add like snap together features or something. Yeah.
Okay, not to ask such a stupid question, but with like the L, the rasterized version, like basically you're telling to us to, what does that mean for us?
Okay, fair enough. So I guess the question was like, why am I telling you that an STL file is like raster as opposed to a SolidWorks file? It's like vector. Yeah. Yeah. Well, I guess STL is the file type that 3D printers and slicers need in order to work for some reason. It just is. And STL is useful to them that way. Unfortunately, SolidWorks doesn't really know how to edit an STL very well, and an STL doesn't carry with it any of the like feature history that you guys get in a like native SolidWorks file type. So it's just two different file types for two different reasons. Once you save something as an STL, you can't really edit it that well anymore unless you get a mesh editor, which is like a whole other thing. It's like a JPEG. You can edit a JPEG, but if you have like the vector file that you used to create it, you'd probably just want to edit that one and then make a new JPEG. Anyway, maybe that's like a poor comparison if you're not like super into the graphics world. Yeah. Yeah, that's a good question. Do different printers have like different qualities, different print at different qualities. Newer printers, like more expensive printers, have a smaller layer size. So in like an inch, it might fit 1,000 layers instead of like 100 layers. And that it will take more time, but it means you just get a higher resolution on the part that you're printing. A higher resolution STL will do better on a higher resolution printer, if that makes sense. For most of the stuff and on like all the default settings, which is again why I just want it to be at like a tangential reference, you're not going to notice any difference, so don't worry about it. Oh, okay, so the question is, this support material, is it more like spaced out, different geometry or different build process than the red solid stuff? It is different. I can try and bring in on Tuesday an example of a part that I haven't cleaned any of the like support material off so you guys can see it. It's that same sort of like honeycombed geometry, and it's like loosely touching the real part. You still have to like clean it off though.
Do you know where the printer is upstairs?
Yeah, they
There's
have like
that jar. Yeah, that, but it looks like that.
That's the art series.
I mean, it's the same material. It's just not the same density. Like it. Yeah, right. I know we've got at least one resident like printer enthusiast here. So, right? Don't you like remelt some of this stuff already, Mitch?
Oh, not for like a print. That's some exploration.
HDPE.
Yeah.
Yeah.
And you can make like machinable stuff. Like,
So give all your support material to Mitch. That's what it's going to.
Very like fun questions. I was like, it seems like a waste.
Yeah. Yeah, you can. I believe PLA is a true thermoplastic. I have to double check that. Thermoplastics can be remelted. They're more recyclable that way. Yeah, quality does like degrade over time, like every time you melt it, but yeah, you can do that. So, okay, anyway, I brought this part in. I saw that, wow, there's a lot of support material here. Let's try a different orientation. Like, maybe I want to rotate it so it prints this way. There is this great little button, lay flat. Lulzbot, or whatever, Cura will, like, predict which way maybe this thing could print the best. It's worth giving it a try. It's not super smart, but alright, let's take a look. Alright, so this still needs some support material. And it would probably need material inside here too. But anyway, this is a tool for you guys just to kind of see how this might print, what orientation the layers are going to, or I guess how the layers are going to show up on your model. You can kind of see like they're oriented this way on the inside. Oh, it's actually pretty dense on the inside. I can zoom in. Wow. They're oriented lengthwise. Down at the bottom of the model, they're like further apart. If that bothers you, you might find another orientation or tweak your geometry to fix that. All right. Any questions so far? The last thing I'll show you, if there aren't any questions, is, and again, just to show you that it can be done, don't worry about splitting any of your models just yet. I'll show you how to like cut a model in half. So when I originally imported this thing, it was way too big. There are a couple ways I can split this, and one way that you can do it is by splitting it with a plane. So I might try and set up a reference plane that's like right in the middle of my object. So let's try this plane here. One way I can set up a reference plane is by like picking the right plane and then dimensioning it to somewhere in the middle, and I'm just eyeballing it right now. Cool, so there's my plane. There is a option under direct editing called split, and it will take any surface. So it could be a plane, it could be some surface that you built, a lofted surface, a swept surface, it doesn't matter. And then you're going to hit, after you pick your surface, cut part. And it will literally cut anything that that surface intersects with. And cool, so it looks like I've got both my halves here. Nice. Okay. And you'll see now I have two separate solid bodies. If I want to export STLs of both of them, I would probably have to do the same thing where I delete one of these parts, export this, like save this as an STL that's like part A, okay, and then I can like go back into this delete feature and say delete the other half, save it as an STL, and call it part B, okay. If I want to go back in time, like, again, that's kind of destructive to the model, but only for the purpose of printing. I can always go back, roll these features back, and like, there's my model. I'll just leave this part suppressed, what it's called. All right, so let's take a look at that really quick in Cura. Delete that.
So like if you need to add support to the overhang,
if you need to add support because of the overhang, Lulzbot should be smart enough to build the supports. If for some reason you import it and you think, oh man, that really should have support, but Cura doesn't seem to be adding it, I don't know that there's a great way to add supports in Cura, but you could build support in yourself in SolidWorks or find a way to chop your model and print it in 2 parts. That's probably the best way to do it. And for this weekend, the reason I'm trying to, I guess, show you the 3D printing side of this at least a little bit is so that it's on your radar. As you're designing these parts, things that are solid and have a way, like a flatter side to print on are going to be more successful once we do actually print them. Yeah.
For the supports, you said it would
Still
like
big.
have to be filed off. Is that like, is it like perforated? Or, like you can break it off and file it?
I mean, you guys should have this. This is another good reason to do this as a 3D printing project because you got to try it. The support material is printed, engineered to be not difficult to remove, but there are some like really flat surfaces. If it's all supported by support material, yeah, you're gonna have to do a lot of scraping to get like all of the support material off. Sometimes you can just like break it right off and it is perfectly fine. It just depends on the model. So you guys will have a chance to see. And like I said, if I can bring something in that still has support material attached, it's like an excavation process.
I spent a whole summer filing flash off of plastic.
Oh, that's fun. It's not.
It was not fun. It was fiberglass. It was very itchy. My hands were
No, that's awful. Sorry, let me
I'm
rephrase.
having really bad flashbacks right now.
Flashbacks? Yeah. No, it's probably not that bad. Okay, so one other, or maybe 2 other little considerations to think about. The thinnest wall that a 3D printed part can have and still be like relatively successful, like the thinnest part you would want to print is probably about 2 millimeters. So like if you're designing a wallet clip for your phone, make sure the thickness of that part isn't thinner than about 2 millimeters. Otherwise, it just isn't going to print correctly. Or it will be too flimsy. The other thing that you'll want to keep in mind is, and I'll give you an example that I can point out here. Let me get rid of this thing. load my frame again. Clearance. So we haven't talked a lot about like engineering a part. One of the things that you'll want to keep in mind is that when the 3D printer prints geometry, it's not always super accurate. There are some tolerancing considerations that you have to keep in mind. And what do I mean by that? So you guys probably saw in Thingiverse, these holes in this quadcopter frame are for a motor, right? My cylindrical motor is supposed to slide into that hole and fit snugly. So far, the way that you guys would have done that is take your calipers, measure the diameter of the outside diameter of the motor, and set your hole size to be exactly that width because you should be able to slide the hole in. In the real world, in the 3D printing world, that's not actually the case. I would give yourself about a 0.5 millimeter clearance on all sides of a part that you want to fit snug into another part. So what that means here, you want to overshoot the size of the hole. Yeah. So like if I measured my motor to be 5 millimeters wide, I would make that hole probably about 5.5 to 6 millimeters wide to make sure that the motor actually fits inside there.
So for something that would plug in this.
Exactly. Yeah. Perfect. So good question. So if you have a 3D printed part that's supposed to fit into like a hole in something that already exists, and that hole is, let's say 5 millimeters, you'd probably want to make that part 4 millimeters to make it fit inside. Have a 0.5 millimeter clearance all the way around.
So it fits from like the center of your.
Yeah.
And then.
Well. Yes and no. But that's an okay way to think about it. Yeah. And that's something that you can tweak in here as well. It does try to keep edge geometry exactly correct, but it's impossible because it's not super. These printers are not like super accurate. For those of you who are like making cases or slots to fit your phone, I would make the slots not exactly the width of your phone, not whatever 5 millimeters. Give yourself maybe 2 or 3 millimeters extra space, so that your phone can slide in and it's not like jamming your phone into a slot, right? And that is clearance. I'm asking you guys to just build some clearance into those holes. And again, it sort of depends. If you're making a case to go around the outside of your phone, you probably want that to be a pretty snug fit. So, like let's say I wanted a case to go around the edge of my phone, and my phone was 5 millimeters thick. I wouldn't make that hole 5 millimeters. I'd make it probably 5.5 to 6 millimeters. Again, every 3D printer is a little bit different. Worst case scenario is if the slot is like too thin, you get a file and you like file it out, or some sandpaper and you sand it out. That's normal. Or you redesign the part and add a little bit more clearance, or if it's like too loose, you can make the hole a little bit tighter. Is that making sense to everyone? I know it's like a very technical thing. Don't get stuck in the weeds here with that kind of stuff, but think about it, and that's why, like for those of you who are designing something to go around a box on the wall, like build that box into your model so that when you build the part that's supposed to fit around the box, you can see and make sure you're leaving yourself a little bit of clearance so that it actually fits around that box.
Another thing I did, I had to take these little round things and put them, make sure they could actually, yeah. Don't work at a factory, guys.
Okay, I think that's most of the things I wanted to cover. Just double checking really quick here. The lesson should be up, and actually, you know what? I brought it up here too. So we talked about slicer. We talked about exporting as an STL. We talked about overhang, feature size, meaning like nothing thinner than about 2 millimeters. 3 millimeters or thicker is better. And we talked about clearance. So, cool. Good luck with your models. I would encourage you to do some thumbnailing, some sketching for yourself to make this design as high quality as you can. This is a big opportunity if you want it to design something that can live in the real world. Hopefully, most of you guys will get a chance to print this. I want you guys to all print this and make a Thingiverse thing and post it, and we'll try and get some people to print this stuff. I've been talking to Idea Foundry about some bigger projects to involve you guys in with a couple other cool tools, so we'll just see how this goes. If you have questions, I know this is like the first big like design assignment where you're not building the same thing as everyone else. Talk to each other. Please email me. I'm happy to walk you through something if you need it. I know I don't have like official office hours or whatever. I'm happy to do a little recording of my screen of something. Like, please consider me a resource for you guys. I want you to accomplish this stuff as much as you can. So, cool. Submit your files. Make sure you don't walk out of here before I have your files from sketch modeling this last time. And we'll see you guys on Tuesday. Oh, this whole thing was live streaming too, so yeah.
The last one,
Quick question.
Yeah.
For the weekend of September 29th and like 30th?
Yes.
Do
Like
you
next
think-
Friday, or is
No,
it
I think
following?
it's the following.
The following, okay.
Do you think I might be going to California that weekend? Do you think